Okay, on to question number 2. It says solve. It's recommended that you verify that your answer is indeed a solution. Meaning that once you find what you think is a solution, if you plug it into the left and right hand side, you should get the same value. Although that's not necessarily going to help in all. Well, it would help for many of these cases. So let's look at the first equation, right? I guess I'm going to start by, I'm going to add 2x to both sides. I'm not fond of negative coefficients here. So I'm going to add 2x to this side. And over here, I'm going to add 2x to this side. Notice I'm very carefully adding a 2x on each side of the equation, right? On each side of the equal symbol. Um, so I can't put 2x, but with this term and then 2x somewhere. It has to be on separate sides of the equal sign. Now over on the left-hand side, right, when I combine a negative 2x and a 2x, I'm left with just plain old 0 there, but I still have the plus 4. So this becomes 4 equals 4x and then minus 16. The next thing I'm going to do is I'm going to add 16 to each side. And as I do that, over on the left-hand side, I get the number 20, and on the right-hand side, I have 4x. And then finally, I can divide both sides by the same value. If you have equal things and you divide by equal things, you get equal things. I'm left with, on the left-hand side, 5, and on the right-hand side, x. So I can say that x is 5. X is 5. Now, I would probably, if I'm taking this test, I'd probably grab my calculator because I'm lazy, and I'd just real quickly go on this one side, what's negative 2, and then I'd hit times 5, and then I'd go plus 4. And then I would say, and I'd look at that and I'd say, okay, on the other side, what's 2 times 5? And then 2 times 5 is 10, and then minus 16. And if I don't get the same value on both the left and the right hand side, if I don't get the same value, then I've made a mistake somewhere, and it's my job to go back in and try and figure out where it is. So take a look at this, verify that this really is a solution, plug in negative or positive 5 for x on both the left and right hand side, and it takes like just a few calculator keyboard strokes, right, to do that. It's not a difficult task, but just verify the solution. Let's go on to question B. Let's see, on B, I'm going to subtract, I'm going to take away 2x from each side. So if I take away 2x from this side and 2x from this side, I end up getting, on the left-hand side, I get 4, and over on the right-hand side, I get negative 10. Hold on, right? Hold on. There's no variable anymore that's going to allow me to manipulate this or change this because I had an equal number of x's on both the left and right hand side. I'm left with this statement that is always false, right? I don't care what you pick for x, this will always be false. And when we get a statement like this that's always false, our answer is there are no solutions, right? You just write no solutions. There's no value of x. It doesn't matter what you pick for x, here or here. You're never, ever, ever going to find a value of x that will make 4 be the same thing as 10. So part B had no solution. Let's move on to part C. Let's see, on C, I'm going to go ahead and I'm going to add 2x to each side. So I'll add a 2x here plus 2x, and over here I'm going to add 2x. Over on the left-hand side, this becomes 0, so I'm left with a 3. On the right-hand side, this becomes 0, so I'm left with a 1 and a plus 2. Well, guess what I've got? I've got 3 is 3. This is always true, right? This is always the case that 3 is the same as itself. So for this particular problem, it doesn't matter what I picked for x, any value of x would be a solution, anything. So for this case, we say the solution is all real numbers. Any value would work there. And then finally, let's look at part D. Part D, here it is. Let's see, I'm going to add 4x to each side plus 4x. So that's on each side. On the left-hand side, I'm left with a negative 12. On the right-hand side, I have 7x plus 9. And I'm going to subtract 9 from each side. So I'm left with negative 12 minus 9. And I know this side is 7x. Negative 12 minus 9, I believe that's the number, negative 21. Yes, it is, because 1 would make it a 8 would make it a negative 20, and negative 21. All right, so negative 21 is 7x, so I'm going to divide each side by 7, right? That's what x is. You can see it. It's negative 21 over 7, but that turns out to be negative 3. So we'll just write down x is negative 3. Again, I highly recommend that you plug that value of x in here and here and verify that it really does make both the left-hand side and the right-hand side the same. If it does, you're assured this is a solution.